Hey, welcome, thanks for being here. We're going to start chapter 6, which is on rational functions. Now, I've said this a few times in other classes, but the word ratio is in rational. So rational, we can just think of it as being fractional. A rational function is a function made up of two other functions. So our function f of x, we think of as being function p of x divided by q of x, where p and q are polynomials. You might have heard the statement, mind your p's and q's. That actually comes from pints and quarts, not from math, luckily. So like back in the day, whenever that day was, you'd be at a tavern getting a drink, and ordering a pint versus a quart was very different, even though the p and the q look very similar. So we mind our p's and q's, p is on top, q is on the bottom. Something you'll hear me say very frequently in this chapter and in this class is to compare it to a simpler problem. All we're dealing with is fractions, right? If you want to be able to add fractions, you need a common denominator. But if you want to multiply fractions, you can just multiply the fractions. So this would become 2x over 15, excuse me. A huge mistake or confusion students have is wondering when and how they can simplify. This rational expression I have on the left can't simplify any further. You cannot try to cancel these 6's to get x plus 1 over 1. It doesn't work out that way. A quick way to check if you ever aren't sure is just plug some number in for x and see if the two things are equal. Like suppose you thought that you could cancel the 6's and get x plus 1 over 1. We'll see if that holds as true for all values of x. Like if x is 8 plus 6 over 6 the same as 8 plus 1 over 1? I don't know why I picked 8 because I draw awful 8s. But 14 over 6 is not the same as 9 over 1. This simplification is no good. You can simplify top and bottom if you have common factors. So here, everything can divide by 2. So if you want to, you can just divide everything by 2 to get x plus 3 over 3. But a nice way to think about that is I can factor a 2 out of the top, and I can actually factor a 2 out of the bottom. And then these 2's can cancel. They divide to 1. When we say cancel, we mean 2 divided by 2 is 1. And 1 times something is just the something. So you get x plus 3 over 3. If ever you're confused about how to simplify or what you can or can't simplify, compare to a simpler problem. Think, what can I do with numbers, and then how does that change with variables? There's a main rule in math. You know, if you had your math 10 commandments, the first commandment would be thou shalt not divide by 0. And I want to talk briefly about why that is. Actually, I think I'll talk about that in the next video. I think in this video I'll talk about some interesting things that happen if you divide by 0. I had a teacher once tell me this little illustration where if you ask a physicist what's 3 divided by 0, they might be inclined to tell you that it actually equals infinity. Because if you take 3 and divide it by something really small, as you divide by something smaller and smaller, something that gets close to 0, this gets closer and closer to something really big. You know, like 3 divided by a half is 6, and 3 divided by a tenth is 30. So as this number gets smaller, this number gets bigger. You can get as small as you want to get the quotient to be as large as you want. So 3 divided by 0 comes out to infinity if you ask a physicist. If you ask an engineer what's 3 divided by 0, they typically are aware that what's happening is just what you have is nothing. You have 0. So even though 3 divided by 0 doesn't actually equal 0, there can be a world where that sort of makes sense. But with a mathematician, we're not sure if it's 0, if it's undefined, if it's infinity, so we just call it undefined, meaning we don't really have anything for it. It's literally not defined. So thou shalt not divide by 0. That matters with everything that we're doing. We're going to have expressions that have variables on top and variables on the bottom, and we have to make sure that we're never dividing by 0. So we have to state that x cannot be in the set of 0 or something else. And we'll see examples of that. But like if I had 1 over x plus 3, I would state that x cannot be in the set of negative 3. Let me show you what I mean. First lesson is on simplifying rational expressions. I often call this chapter factor and do things, because that's what ends up happening. We factor, and then we do things with the factors. Remember, whenever you're factoring, to look for a greatest common factor first. This has no greatest common factor, so I can't pull one out. And just so you know, I see how hideous this 7 is, and it bothers me more than it does you. The first problem I wrote didn't work out super well, so I had to change it a little bit. just know that, I die a little bit inside when I see this screen. But the top can factor into x with 7 and x with 1, and I need the 7 to be positive and the 1 to be negative. The bottom can factor, the denominator can factor into 8 and 1. It's x minus 8, x minus 1. Now I've got whole entire factors that can cancel. So this factor cancels with this factor. They divide to 1. I'm left with x plus 7 over x minus 8. Notice I can't try to cancel these in advance or try to cancel these in advance. If something has a plus or minus next to it, it's not going to be able to divide or cancel. You have to cancel whole entire factors, not just parts of things or things with plus or minuses next to them that aren't just their whole factor. Now that I've canceled and simplified the top, I have to recognize if on the bottom x were to equal 8, the bottom would become 8 minus 8, which is 0, and I would have something on top divided by 0, which is undefined. That's no good. We can't be dividing by 0. So we have to specify in this expression the domain is such that x is not 8. This is a C with a line through it means as an element of the set, and I'm stating it can't be an element of the set 8. So you need to both be simplifying but also discussing what x can and can't be. That's the main game we're playing here. X can't be 8. It can be anything else. We don't care if the top equals 0, so x equaling negative 7 is not a problem. The top equaling 0, anything with 0 on top is still just 0. That's not an issue. It's 0 on the bottom that becomes a problem for us. Okay, let's throw in some multiplication. I'm again going to compare to a simpler problem. If I have something like this, before I do the multiplying, 3/4 times 8/15, I would see what I can simplify. 3 and 15 can both divide by 3. 8 and 4 can both divide by 4. And I would just make this 2/5. So I would simplify by reducing before I did any multiplying. I'm going to do the same thing with this rational expression on the left. 10 and 5 can become 2 and 1. There's 3 x's on top, but only 1 x on the bottom. So 1 on top can take away 1 on the bottom. This goes away, and this becomes x squared. There's 2 y's on top and 5 y's on the bottom. So 2 of these take away 2 of these. This becomes y to the third. This b cancels entirely with this b. One of these a's cancels with one of these a's. I don't think anything else can factor. So what I'm left with is on top I have 6x squared times 2a squared. And on the bottom I just have 5y to the third. It kind of got tough to read. But combine all that, I'm going to say this is 12a squared x squared divided by 5y to the third. And I have to remember that y cannot be 0. If you write it that way, that's fine. I'm trying to get in the habit of using this set notation more often. Y cannot be in this set of 0. And there's the simplification. Notice here the fact that these two problems are the exact same, right? If I clean up this one a little bit, this expression and this expression are so very close, but this plus 7 and this plus 11 ruins everything. There's no factoring or simplifying I can do because I can't cancel whole entire factors. There's addition at play with the multiplication, so I have to think of this as one single term. Now, this was also one single term, but it was one single term that was actually broken into separate factors because everything was in terms of multiplication. Throw in some addition and you can't cancel anymore. So this is already simplified, and we'd have to state that a, b, x, and y all cannot be in the set of 0. Because if any of those are 0, you're dividing by 0, and that's undefined. Okay, take a second and see if you can solve this one on the left. Just factor it first. It looks like a real mess, but problems like this are nice because they tend to factor really pretty. Pause, try to simplify on the left, and then if you want to, go for the right. I like to cheat a little bit when I do this. I see an x minus 8 here, and that makes me think there will probably be x minus 8s at other points in my factoring. So for example, down here, this is actually just x minus 8 squared. And up here, this is, I think, x minus 8x plus 2. Gotta stop using so many 8s. And this factors into x plus 3x plus 2. Now for the real gratifying stuff. One of these x minus 8s cancels with one of these cancels with the other ones, so there's two x minus 8s on top and two x minus 8s on bottom, and they both disappear. Let me change color for all that line drawing I'm doing. An x plus 2 kills an x plus 2. We have nothing left on top. That doesn't mean that we have a 0 up there. Remember, I keep saying these are dividing to 1. When everything's divided, you get a 1 left over. This becomes a 1 over x plus 3. Therefore, x cannot be in the set of 3. Boom, we simplified. Now maybe you see this and think, oh, division, we haven't done division yet. But do you remember how to divide, like, simple fractions? My hope is you do. You take the second fraction and you flip it over and multiply. You multiply by the reciprocal. Never divide fractions, always multiply by reciprocals. And then I would simplify and cancel that. So I'm going to take this right here and flip it over. I'm going to factor the top left as I do. So the top left is x plus 5 squared. The bottom left is the difference of squares, x plus 5, x minus 5. On the top, I'm going to flip this over and factor it, but I guess I'll do the flipping first just to not get too confusing. So I have 2x squared minus 28x plus 90 over 2x squared minus x minus 1. Okay, now I'm going to factor the right side. So the top, x plus 5 squared stays here, then x plus 5x minus 5. Here I can factor out a 2, giving me x squared minus 14x plus 45. Don't forget to look for GCFs. On the bottom, I can't factor out a 2, so I'm going to see if this can just factor 2x and x. I'm going to cheat again. Nope, 5's not going to work. 1, it's going to have to be a 1. I guess I didn't really cheat there. Make this a minus and make this a plus. One last round of factoring, I hope. X plus 5 squared over x plus 5x minus 5 times 2. I think this is x minus 5x minus 9. Okay, good. The factoring is done. Now let's start killing things. X minus 5 and x minus 5 cancel. Oh, is that it? Is that all that cancels here? Yeah, no, there's 1x plus 5 here and 1x plus 5 here. Those cancel. But I think that's it. So what I have left is a 2. I'm going to put the 2 first, times x plus 5 times x minus 9 over 2x plus 1, x minus 1. You might be tempted to go through and redistribute the top and the bottom to make them single-looking polynomials. Don't worry about that for now. Seeing a polynomial in factored form is really nice because you get to see what the roots are and what the zeros are. Seeing a polynomial in standard form is nice because you get to see the y-intercept. But we won't worry about that extra step and leave it here for now. So x cannot be negative 1/2 and 1. Don't forget about that, what x can't be. How did I get those things? Well, I took my factors on the bottom, and I say, okay, I know 2x plus 1 can't equal 0, so I set up that equation, solve for x. 2x can't be negative 1, so x can't be negative 1/2. That's where this came from. Do the same thing for this, and x can't be 1. So you're going to take your factors of the denominator, set them equal to 0, and see what value of x gets me out of 0. I can't have that, so I pull it out of the domain. It's not inside the set of what x can be. Here's the same problem twice. I want to show you a very key and kind of fun distinction we can make. The top here factors into x plus 5 squared. The bottom is x plus 5, x minus 5. One of these x plus 5s on the bottom and one of these x plus 5s on top divide to 1. So we get x plus 5 over x minus 5, and x cannot be 5. 1 down. This is very similar. x plus 5 squared over 5 minus x, 5 plus x, you'll note that x plus 5 and 5 plus x are the same thing, so one of these and one of these can divide, and we get x plus 5 over 5 minus x. Nothing here can cancel. This can't go any further. X still can't be 5. But if you have this sort of scenario, where you have two things subtracting each other, but they're in opposite order. For example, if I had x minus 5 and 5 minus x, which we hadn't seen in these two problems. But if I have something like that, then these divide to -1. This can just simplify straight to -1. Let me show you why. On the top I have a minus b, on the bottom I have b minus a, but I can switch the order of this b minus a and call it -a plus b. Now right now the a's and the b's still can't cancel, but if I factor out this negative from the bottom, on top I have a minus b, on bottom I get a minus b, but I pulled out a negative to get that, so it's negative a minus b. Now these reduce to 1, the negative is left over, it's just -1. So if you have a minus b over b minus a, that just simplifies to -1. This probably looks horrifying to you, but just calm down, okay? Everything's going to be fine. It's a fraction of a fraction inside a fraction. It's incepted fractions. But this just means x squared minus 9 over 8 divided by x plus 3 over 4. That's all that means. So split this up into one big old division problem. Take the second fraction and flip it over. And flip it over correctly. You have x plus 3 times x minus 3 over 8 times 4 over x plus 3. These cancel. The 4 and the 8s can become 1 and 2. We're left with x minus 3 over 2. There's nothing that x can't be in this case. We don't have any variables on the bottom, so x can be in the set of all real numbers. There's nothing that it can't be because there's no way to make the bottom equal 0 if there is no x on the bottom. Like, think about all the times in your life you've written 2/3. You've not all of a sudden said x can't equal -3 because that's nonsense. If there's no variable in the bottom, nothing has to be excluded. To recap, simplifying rational expressions follows the same rules as simplifying any fraction. You can factor everything and then cancel common factors that are dividing, and compare to a simpler problem whenever possible, whenever you're feeling confused. There we go. You did it! You got through the video. Thanks for watching. I'm going to play with the perspective of these shapes, which is always pointing towards that center while I talk to you about things. Please subscribe to the video, the channel really. Please like it if you found it helpful. If you want to share it with friends and say, hey, this guy's not the worst, that's an option too. You can always take your video quiz if you're in my class. And comment down below. See you next time.